All right, guys. Anybody have any questions you want to start off with? We had some good ones during my office hours. No, you guys, no, interesting.
No.
Good. There's two of you. One of you, go ahead. Let's see. Carly, did you have a question?
Yes. So for on the homework 11.2 question 73, it has two tables on the question.
Yes. Okay, good. Beautiful. I love it.
So I filled out the whole first table and I found the chi-squared. But I'm not sure why
No.
they're not supposed to find it for that table.
All right, so there's not really two tables. In fact, real quick, hold on. And you're like, Jeff, look, one table, two table, Jeff. All right, now listen. We did this worksheet together. Hold on. Where are you? Come here. Come on. There you are. Come here, you. Didn't we do this worksheet together? And look at this problem. Isn't this a table and isn't this another table?
Yes.
All right, what was this? This isn't really a table, is it? It just gave me the way to fill in this column on my main table, the one table I'm going to use, right?
Yeah.
Okay, now, so looking back at this, I really hoped you could see that. Okay, looking back at this is exactly like this. It's how you calculate the expected, and these are your observed. So neither one of these is your table. You're going to construct your table. Here's the observations. Calculate what the expected ones are going to be, right? Because you know there's 400 total. Are you with me?
Yeah.
How many would you expect to never have been married? How would you figure that out?
You would do 400 and then divide it by the categories, and there's 4 categories, no? Or would you multiply it by the percent of the category?
This is not uniformly distributed because they told me exactly how it's distributed. So what percentage of the 400 should be in this category?
What percent or?
Yeah, what percent?
Can
you see what I'm doing?
So the 31.3.
Yeah, 31.3% are in this category. So how many are in that category? 31.3% of
400.
400. I like it, which is exactly what we did on this problem to figure these out. We did 20% of 500 and 30% of 500. Yeah.
Mm-hmm. So it should be 125.2.
Whatever it is. That sounds about right. Yeah. So neither one of these is your table. This is how to figure out the E's, right? The expected, and this is how, and here they give you the O's, the observed. So you make your table using both of this information. Does that make sense?
Okay.
Okay. So neither one of those is the table. It's just information.
Okay.
Information.
So just go over it. The frequency is the observed, and then the percentages are the expected, or the other way around.
Yeah, frequency is just another. Frequency is our observations, right? Remember, we're making a frequency table, then we count how many people were within something. That's our observations. Yeah, so this is just another way to reference observations.
Okay.
Yeah. The expected amount in each category, or otherwise expected frequency, then would be the E's. Yeah.
Oh, okay.
Now, let me see. Somebody's asking me, what questions are you talking about, Melody?
There's a couple questions. I think 79 in section 11.2, which that one I did not answer fast. But there's also the ones in section 11.1 that was 69 through 71.
So right here, if you just follow the instructions, you don't have to explain.
You don't want to? Okay, that's fine.
Yeah.
Okay, thanks.
If I had written the question, I would have said explain your answer, but they didn't. I didn't. They didn't say that, so.
Okay.
Too bad for Jeff. Okay, how's everybody else? What do we got? 3 classes left. And then you don't have to look at this mug anymore if you don't want to. All right, so let's do this. Let me see. So we did that one. I like it. Let's do this. Let's do the let's do another goodness of fit problem. And then we'll talk about section 11.6 a little bit. Let's do the one that's on the practice final. Why not? In fact, I think I might not have done this problem on the answer key, but well. So does everybody still know how to get to the practice final? Come on, Jeff. Modules. Let me become a student. Become a student. There we go. Very first thing is the practice final. Bam. So if you can't find it, I'm not sure what to do for you. So let's do the very last problem on here. The grades problem. Yeah. Let me open this a different way. Hey. I am learning. There it is. Doobie doobie doo. All right. So the very last problem on here is just like the problem we were just talking about with the 2 different tables. This one is going to be a little bit grosser. I think I'm going to show you how to do this in the calculator. That might be a good idea. So let me let you guys do this. What are you going to put in this column here?
Use the percentage times the number. No?
Use the information they give you in the questions.
What are the observations that somebody made? How many A's did they observe?
51.
51, so that would go there and so forth. Okay, all right, so let's put that down there. So that's the easy part, right? The observations pretty much have to be easy. I have to just tell you what somebody else saw. And hopefully that makes 342. I don't know if past Jeff was doing math right. Now, let me see. Let me get you guys to maybe buy into what I'm about to do. Now come at me, whoever was telling me a minute ago. How do I fill in like the expected? How do I fill in this first spot under the expected column? What would I have to do?
You use the percentages and multiply by the sample number.
Yeah, what's 13% of 342?
44.46.
44.46.
44.46. Okay, so let me show you this. I'm going to stop sharing now. Ha ha ha. Ha ha. There you go. Too bad. Let me open my calculator. Dadgummit. Jeff, try again, buddy. All right, hold on. There you were. Okay. So let me show you something. It's up to you. You can do this or not. Hold on. Here it comes. Any day now. It's going to happen. It's going to open. I know it is. All right. Well. Is it going to help? Maybe not. Shit. What's going on? There it is. Good Lord. All right, I'll stop. Sorry, bro. So let me share this with you. Bam. Remember this thing? I didn't get ice cream and now I want it again. Damn it. So let me do this. I'm going to go into my lists. I'm going to clear them. And again, you don't have to do all this if you don't want to. So let me put in here this information. What do I got? So I got 51, 63, 41, 60, 37, and then look what I can do. 342 times 0.13. Bam. 342 times, where'd it go? What would I multiply for the second row? Do you guys still see that? Are you guys with me out there? I can't even see you. Am I still here? Okay, there. I wasn't seeing you. You're all shaking your heads up and down. I'm like, I don't even see that window. All right. Can somebody still see the sheet? What's the next percentage for B's? This is A's. That's why we did times 13%. What am I going to do for the B's?
20.
20%. I like it, so 0.2. And then for the C's?
34.
34. And then it's symmetric. That's the expected bell curve. This is actually roughly the percentages amongst 5 categories in a normal curve. Very roughly. If you don't know what I just said, that's okay. It's symmetric. There's 20 again, and then here's the 13. I didn't even have to do all this because I already know what these are. Let the calculator worry about all the decimals, right? Then I want the next column to be observed minus expected squared, right? Right. Just in case I have some people out there that didn't access the practice final, right? Don't I want the next column to be observed minus expected squared? Where's the observed? It's in L1. Where's the expected? L2. So what I want L3 to be, I want it to be L1 minus L2 squared, right? No? So I can go up here and make this parentheses L1 minus L2 squared. Bam! And then I want this one to be L3 divided by the expected, which is L2, right? Are you guys okay out there? Again, you don't have to do all this if you don't want to. You can do it the other way.
What did you put for L4 again?
So L4 has got to be observed minus expected squared, which is L3, right?
Okay, so just L3 squared.
No. L3 is already observed minus expected squared. Let me show you again. Right?
Oh, that's right. And then the fourth one's
Just- I
divided
just need it
by
to be L3
L.
divided by L2. Yeah. So up here again, I can do L3 divided by L2. Bam. And then do you guys remember? Oh, I see some worried faces. What's up?
I just like, I don't know. I don't know how this happens, but I just have like a couple decimal places less than you do.
Oh, because my calculator is awesome.
Oh, okay. Well,
Sorry.
doesn't really matter though.
So evil. Yeah, this calculator, 2 things. It's using a higher processing power of the laptop. It's got a wider screen for showing more places. And
Oh, okay.
it's emulating like the best, the TI-84 plus C silver edition. Watch out. So,
Okay.
yeah. So
That makes sense.
don't feel inadequate compared to my decimal places.
Right.
So what do I want to do with this column? I'll tell you what I want to do with that column, Jeff.
L3 divided by L2.
I've already done that, right?
Yep.
That's what they are. What do I want to do with those values now?
Find the sum.
Sum them up. You guys remember how to do that? You hit second quit, go to second stat to go to list, Math, sum, do you guys remember this? Sum up L4. There's my chi-squared. There it is. Did you have to do it in the calculator? Of course not. You could do row by row by row like we were already doing a minute ago. I just wanted to show you how the L1, L2 stuff would work if you wanted to put it all in the calculator. It's just a little bit quicker. So I'm going to transition back to the sheet here. All right, so let's see. Here, what was it again? So we did, oh, eraser won't work well, Jeff. Here we go. So we did blah, 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 blah. And we finally got, what was it, 5.535? Is that what it was? Yes. All right, now, this is kind of weird. And somebody said earlier that not having the 5 steps kind of tripped them up. I don't think you actually want me to make you do 5 steps for this, do you? In fact, I'd have to actually teach you more to be able to do all the 5 steps. But we're kind of doing this backwards. This is like Z star, right? Somebody the other day said it was like chi-square star, right? It's the one we calculated. So now I'm going to go back and figure out where is the benchmark? Where's the rejection region? Where's the practice final? It's the very first thing. It's literally the very first thing. Let me show you. Oh, can you see it? Let me know if you can see it. That's all right. Okay. So I know that alpha is 0.05. What is the alpha? What's the degrees of freedom?
4.
4. Good. It's category, number of categories, -1. I like it. And now I just got to look at those two things up. Good old Java. Oh. All right, let me show that again real quick. You guys, while I show this again, try to look that up on the chi-square chart. Right? Let me show somebody this thing again here. Oh crap, too many buttons. So you go second stat to go to list. Because I want to do something to a list. I want to do math on a list. I want to sum the list up. And then you got to tell it which list. Man. Oh, I got to open my chi-square chart. Chi-square, where are you? You're nowhere. You suck. Wait a minute. Oh. Hold on. Hold on to your butts. Here we go. All right. All right. I know. I just opened you. Here we go. Somebody chatting at me? So you said 5 is like? No. Okay, listen, guys. I love you guys. Chi-square. That. All right. Here. Can you guys see the 5.535? That is like Z star. That's the chi-square that we calculated for our sample. And I said somebody the other day called it chi-square star, which I didn't necessarily want to use that symbology because, or symbolism, I don't know, that notation, because it's got a lot of shit chi-square star, but does that, I don't know, some of you guys might not feel comfortable enough with hypothesis tests for me to say this is like Z star, but it's the thing we calculated from the sample. So now we know how far away our sample was. We still got to figure out, we actually need to know what was our benchmark? Where's the rejection region start? Did we make it far enough away? I don't even know what far enough away is. So did anybody look that up on the chart? Alpha's 0.05, 4 degrees of freedom.
9.488.
Yeah, so 4 degrees of freedom. Alpha's 0.05. 9.488. So that's where our rejection region starts. That would be where enough evidence would be to show that it's different, that this distribution is different than expected. But we landed at 5.535. Cool. Yes, maybe. So then did we find evidence that this distribution is different? Did we find evidence that they do not follow the expected pattern?
No.
No. So that's what we say. We have not found evidence that this group does not follow the expected pattern. We have not found evidence. Holy, what? That this group does not follow. Oh boy, the expected pattern. In this case, we have not found evidence that these grades aren't normally distributed. Now the double negative, this is why English has finally come around and said we're fine with the double negative, because sometimes it means something. If I take both my negatives, did we find evidence that the group does follow the expected pattern? No, we didn't. You can't. That's impossible to do. We just haven't found enough evidence to say that it doesn't. Okay, maybe, I hope. No, you guys hate this stuff? Does it make any sense? Are you guys okay?
So to know that we did not find evidence to disprove it, the chi-squared has to be above the alpha value.
All right. Alpha, you're not going to compare chi-square with alpha because chi-square is an amount and alpha is an area. So
Yeah, the alpha value that you get from the table.
Oh, the rejection region chi.
Yeah.
Yeah, again, it's just like with normal hypothesis tests, to find evidence, I have to make it in here. We didn't make it in there, so we didn't find evidence.
Okay, thank you.
We're looking for evidence that they don't follow the pattern. We did not find evidence that they don't follow the pattern.
So it's not different enough to make it suspicious.
Exactly, or not even suspicious in this case. I mean, you guys all, a lot of people have heard a little bit about the bell curve, and normally what they've heard is the terrible stuff. Expecting things to follow a bell curve is a really idiotic way to go through life. So when teachers try to correct things to follow a bell curve artificially, that's stupid. Anyway, sorry. So there's a lot of controversy because people misuse it, right? Why did I talk about that? I forgot.
Can you scroll to the bottom of the page?
I am there. Sorry.
Okay. For some reason, I can't see the very bottom.
Here, I don't know what I can do to help you. Let's see. I don't know. Sorry. So it just says we have not found evidence that this group does not follow the expected pattern. So that's the way science works, real quick, kids. I don't know why I just said kids. We have not yet found evidence that gravity does not work the way we think it does. Have we proven that gravity works the way we think it does? No. We just have not yet found evidence that it doesn't work the way we think it does. That is how all science works. You basically are constantly trying to disprove something, and it gets more and more backing the less and less we're able to disprove it. Now, that's a really pathetic way to describe science, but it works for me. Anything about that? Did I take it away too quickly? Oh, yeah. Okay, we're going to talk about that today. Somebody's asking me about the two sides of the chi-square chart. In fact, maybe I'll talk about it right now. So 11.6. Let's look at 11.6 real quick. Do 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 do. 11.6 is remember. Does anyone remember this? This was the very first chi-square formula I gave you. When I think chi-square, my head goes immediately here first. Not the one that we use for goodness of fit, but this is the one that's used in most applications. So you can actually do a full hypothesis test on a sample, on a standard deviation by using a sample standard deviation. So this would be like the step where you calculate Z star. This would be the formula. This would really be chi-square star. All right, I love you guys. Let me, all right, so watch. I will do one thing here and then I will tell you something neat. Let me pull back up the chi-square. Where are you at, chi-square? Oh yeah. Somebody was asking me in chat, what the hell's up with these things, right? So let me show you one example. So if I was testing, all right. Stay with, oh, wait, do I have to do that? No, I don't. I can use this. Ha ha ha. All right, sorry. If I was testing, if I had a claim that sigma is not 11 for something, right? Sigma is not 11. Which one would that be? H up. This is an H, by the way. Oh my God.
Uh-huh.
Don't laugh at me. No, you're right. It's the ha. So it's sigma is not 11. Sorry. All right. How many tail tests would that be?
2.
Good, right? So there's a sigma there. We're talking about saying who gives a shit? It's not equal to, it could be either way. It's a two-tail test. So let me ask you this. All right. So it's two-tail, right? Two-tail. So let's say that our degrees of freedom are 15, right? So this would be, don't freak out. This would be all in the problem. They'd have to tell us the sample size and all that kind of business. Degree of freedom, let's say, is 15, and alpha is 0.01. We'll put that somewhere else. No, okay. Alpha is 0.01. Do you see how there's, in fact, I've drawn my picture horribly. Guys. Why did I draw my picture wrong? Because this is not a normal curve, is it? This is a chi-square curve. That's what standard deviations do. So there's going to be one tail and another tail. Can somebody tell me what area is in this tail up here? You can do this. You can do it.
0.005.
Beautiful. Anybody see where that came from, right? Yeah, because there's 1% in both tails. So of course there's 5.05, or you can do it, 0.5% in that tail. So of course, in back here, there's going to be how much in this tail? 0.005, right? Stay with me. You guys.
Even though it's not symmetrical?
Exactly. Even though it's not symmetrical, we still chop it so that there's the equal amounts in both tails.
So one tail is going to be longer than the other, but
Yes.
the area in total is going to be the same.
Yes. So the non-symmetry of these problems is weird in respect to what you just said, and in respect to, I don't have any negatives, do I? This is 0. So what's this chi-square is going to be right here. Degrees of freedom is 15. So there I am right there. You guys see that? 15? Is that too far down? You guys with me? 15 degrees of freedom, 0.005 to the right. So that's the chi-square right there. That's 32 point, can I write out here? No, shit. 801, okay. So how do I find this one? How do I find this one? And again, this is just like a two-tail z-test where it was negative 196 and 196, but it's not symmetric around 0. So I'm not going to have any negatives. So I'm not going to have the same number. Too bad for us. So can somebody tell me what area is to the right of this one? If there's 005 here, what's to the right? Because that's all this chart understands. Yeah.
0.995.
995. So isn't that right here? So what am I going there, 4.601. So what's really neat to me is if I was here, I would be here. Do you see how it's symmetric in terms of how the table is broken up? I don't know if you guys understand what I'm saying. So now I would have to find a chi-square from a sample that was less than 4.601 or greater than 32.801. That would be my rejection region. So the one who thinks it's equal to 11 thinks it should be in here somewhere. And the one who thinks it doesn't equal 11, it should be out there somewhere. I don't know if you guys followed me there.
Wait, could you say that one more time?
So it's just like hypothesis tests we did before. Where does HO think the sample's going to show up? Doesn't he think the sample's going to show up in the middle? Where does HA think it's going to show up? Out here. So it's very much similar. Now, let me make my big announcement. I'm going to make 11.6 extra credit. You see why I didn't want to say that first? Because then people would have gone to get a sandwich or something. So I don't need to listen to this guy. It's extra credit. Screw this guy. I'm there. So in case you have the time and want to try out 11.6, you totally can. It's extra credit. If you don't have the time because you're in a 6-week course and the final is Thursday and holy shit, then you don't have to do 11.6. But I at least wanted to show you the bare bones of what a hypothesis test for standard deviation will look like. Okay. And if you go on into psychology or something, you're going to kind of build off of what we've done and go further with it. So in case you don't realize what just happened is we're done. We're done with the semester. Now begins the review process. Right? I figure why not? Why not give you a little bit?
Mind bringing up the screen really quick again?
Yeah. Let me write this better. This is 32.8. So I really want this to make sense. Whereas in the past, we might have had negative 1645 and positive 1645, right? For a two-tailed test, you with me? And then Z star would have to either be greater than positive or less than negative. Same thing, chi-square from my sample has to be less than this or greater than this to show that it is different.
So chi-squared is an area?
No.
That doesn't make sense. That's why I was like,
No. So look here, negative 1645, positive 1645.
Oh, okay.
Z star would have to be less than this. So exactly the same way, chi-square for my sample. Let me erase some shit here. All right, chi-square for my sample would have to either be less than 4.601 or greater than 32.801. And then we could reject the null, support the alternate.
But chi-square refers to, like, z-square refers to however many standard deviations a point is from the mean.
What?
So.
Oh.
Sorry.
Yeah, Z star or Z. Z is the number of standard deviations from the mean to the data point, right?
I guess in this case, chi is representing. I'm confused on what it represents.
So chi-square is not quite the same thing because notice how the numbers are not really normalized.
Mm-hmm.
Well, they are sort of for each degree of freedom, but not overall. So, but chi-square still represents a distance from this hump in a way.
Okay.
Yeah.
I guess when I look at the score, I think central, the middle of the box is area, and my brain went to area, but I knew that that didn't make any sense.
Oh,
Because in the z-score,
where are
the
the
teacher is the
areas?
area.
Where are the areas? In fact, this is more like the T-score chart
Mm-hmm.
because see, the areas are up here, aren't they? Just like on the T-score chart. So these are like T-scores. So they're not areas, they're chi-squared in this case, but they're sort of like T-scores. Okay. So some of you guys are like, I have no idea, but I don't necessarily have to worry about it. So, but again, if you're going to go into psychology, like I said, or some business stuff, like some economic theory courses or whatever, you're going to get deeper into chi-square. You're even going to talk about a different distribution, the F distribution, right? Believe it or not. Anyway, that depends on where you go from here. So now it's wide open to whatever you guys want to go back to and discuss. If nobody's asking questions, you can ask a question from quiz corrections, midterm corrections, homework stuff. You can ask questions from the practice final. You can ask questions from chapter 1 homework. You can ask questions from the practice midterm. You can ask questions from that you dreamt about that related to statistics, hopefully, right? That would be good. Did anyone have any statistics dreams? You're dreaming that signals.
I have a question.
Okay, I thought you had a dream. Damn, I was all right, go ahead.
So for the homework, you know how for some of the assignments, like you put a X mark. Can we just redo the assignment?
What do you guys think?
Yes.
Yeah. So what's that shirt? There's one shirt that I still need to get.
It's in the syllabus.
Yes, it's in the syllabus. So I mean, and I keep saying this. So you can do midterm and quiz corrections. You can do homework corrections. Where'd they go? Do on the day of the final exam. Quiz corrections do on the day of the final exam. Yeah.
Okay.
Let me see. I think this is. Here we go. 1 ABC on the midterm. Okay. Let's see. Now, since everybody had different midterms, I'm not going to answer yours specifically. I'm going to talk about the idea. So let's see. Oh, this was okay. All right. What's the question? So here's an example midterm that some of you guys had. Some of you guys had different versions than this. Oh, let's see. How can I show this better? Darn it. All right.
Could you zoom out?
Yeah. All right, there we go. All right, so the very first thing is make a relative frequency distribution. So I think there was 1 or 2 people that got confused. I mean, well, actually, there was like 7 people that left all the zeros out. That's evil. Those are people, aren't they? Don't these represent people? And you're leaving them out. What the hell? So yeah, those are valid data points. I don't care if you don't like the zeros, they have to be included. They're valid data points. Now, of course, what does that mean about these people? They just don't work, or they didn't have hours for a long time. I don't know. What's the question though? I need it because there's a lot of ways I could go with this, but what's your question? Go ahead, Billy. Go ahead. Coming. Okay. Okay. All right. Well, while he's doing something, anybody? Let's see.
Professor, I have a question.
Yes.
For the quiz 4 corrections, I just turned them in yesterday. And before turning it in, I checked my answers with you, and then I still got some wrong, and I don't know how.
Oh yeah, totally. I mean, so if you just verified answers, that doesn't mean that your work was correct. So let me see. Here we go. Yeah, like the very first one, we had talked about that. You had to subtract those. You still didn't give me. Oh, you subtracted the z-scores. No. You got to subtract the areas. 1C, I don't think you checked that with me. I would have told you that was wrong. Same thing with yeah, I think some of these you checked with me the numbers, and those look good, but then some of them you might have checked with me the idea of how to do them, but then it didn't work out right.
Okay.
Yeah, because the two I'm seeing, the two main ones that were wrong, yeah, those are two you didn't check your numbers with me. Everything else, I remember you checking your numbers with me. So for example, with P57, wouldn't the 57th percentile be above the mean? Shouldn't the z-score be positive for that then? So I'm not sure how you got the negative z-score. But you can ask me later if you have more specific stuff.
Okay, yeah, I'll look it over.
Okay. The floor is wide open. If nobody's asking any questions, feel free, throw them in chat. Go ahead.
I also have another question. So I missed the quiz, and you told me that the next quiz will replace the score of that quiz.
Never. I never replace a quiz with a quiz. So if you missed the quiz before the midterm replaced the quiz grade. If you missed the quiz before a final, then the final replaces the quiz grade. Yeah.
Oh, okay.
Yep.
So should I take that quiz that I missed?
No. I mean, you can, and you can say, "Can you look at this just to let me know?" Because you're not going to get a grade for it. So your grade will be the same as your final. So it's not going to be a 0. It's going to be whatever you make in the final.
Okay.
So I've set aside a big chunk of class today and and then basically the whole day tomorrow. Now, of course, tomorrow could include stuff on the quiz that I still need to grade. The quiz that's happening right now, everybody remember, due tonight. While I'm thinking about it, I'm going to make sure nobody's taking it right now. If so, I'm going to kick them out. Nope. Okay, good. All right. So that's quiz 6. You still have until midnight tonight to take that. So I'm going to grade those. So that can be part of what we talk about tomorrow. You emailed me your question. Okay. Oh, geez. All right. So this is all right. Yeah. So you can hang out after class if you have a specific question about stuff. Okay. Oh, man. Hold on. Sorry. Bam. All right. I love you guys. I don't know if you understand. You could ask anything that's trouble. You can say, Jeff, can we do another example of a hypothesis test of a percentage that's 2 tail? Or you could say, can you explain binomial again to me? I mean, so you can have a very specific question. You can have a very general question. You could have a very specific, this is on the practice final, number 4, part B, the second part, right? Anything.
Professor.
Yes.
For the midterm, the corrections, I remember checking my answer 2D with you, like the work and the answer, but it's still wrong. So I don't know, like.
All right, we're gonna have to talk about that later.
Okay.
I would definitely not have told you that a wrong answer was right. That would not have happened. But what normally happens when you get help is sometimes you'll check the idea of what to do, and then you'll do it, and you didn't quite get the right number somewhere, which is what happened on both of those problems. Yeah. So you might have checked with me what you were doing, but you might not have checked with me what the number was that you got for that problem. Have you guys tried the practice final, or are you in homework right now and having issues with a problem? This is the time to ask. Or maybe I should just go ahead and teach 11.6. I don't know. Make it,
For,
Yeah.
for chapter 9, for the it was the section with where sometimes it's like asking if something is equal to, it's easy if I just pull it up, hang on. Okay, so I think it was 9.5, question 49. If you go into it's asking mu is equal to 9. And so for the null hypothesis, mu is equal to 9. For the alternative, it's less than 9. And I was confused because I didn't know you could do both an equal and a less than in the same question.
So I did talk about this a little bit. There is a school of thought where HO is always equal to, no matter what. Oh, crap. Go back. Right, I did bring that up. Oh, crap. Hold on. There we go. But who cares? They could put whatever kind of weird shit they want to here. What thing tells me where the rejection region is? What sets that up?
The alternative hypothesis.
There you go. So I want you to realize you have a valid question. This is weird. It's not the way I do things. And I think, like I said, my hypothesis is that one of the authors does things this way and the other ones don't. And that's why it's like sometimes one, sometimes the other. But what answers this question is this, right? Okay. But again, you have a valid question. It's a concern. You're like, wait a minute, is that special? No, that is just some statisticians think that should always be equal to. And I disagree.
Okay, yeah, that makes sense. My other question was, so this is kind of going all the way back to chapter 1 real quick, but
Yeah.
there's cluster, systematic, stratified, and then random sampling. And then I remember that they brought up something called simple random sampling.
All right.
And I was just wondering what the difference between simple and regular random.
All right, so we actually never went over that. I was waiting to see if anybody would ask me about it, but I didn't necessarily purposefully leave it out. So it's a little bit weird, and it's not that crazy though. It's random sampling is every individual has the same chance to become a part of the sample. Do you guys remember that? That's what makes something truly random is. That's why calling people over the phone to ask their opinion is not truly random, because not everybody has a phone. So there are elements of your population that have no chance to be in the sample. Simple random sample is every group of size whatever that your sample is has a chance to be the sample. Let me say this again. So random sample is every individual has an equal chance. Simple random is every group of size whatever has a chance to be the sample. So just to give you an idea, on my Zoom screen right now, I see several rows of people. So what if I picked one person from each row of people? Are you guys with me? What did I just say? One person from each row? Would that be random? Yes, because every single person has a chance. Would that be simple random? No, because the first row, do they have a chance to be in the sample together?
No.
No, there's the difference. Simple random is just a little more restrictive. And why does it make sense? I always think I'm going to bring this up later and I always forget about it, but it makes sense because later we talk about groups, don't we? Change the standard deviation to work for groups. right? So then we want a simple random sampling method so that every group would have the same chance, as opposed to every individual when I have chapter 6 stuff where we didn't take samples. Does that help? And there's no reason to get that specific in the distinctions with what we've done, but that's what it means when it says simple random. It's just a little extra restrictive. Not just one person, but every group of size whatever has to have an equal chance. Okay, I got several chats to catch up on. Any other opportunities to get raises? Do you have points to raise my grade? What are all the ways you can raise your grade?
Corrections,
Corrections,
Corrections to what?
homework,
homework, quizzes.
midterm.
And not the final. Good. Final's final, right? What else can you do to raise your
Extra credit.
extra credit?
Extra credit.
Extra credit homework. I love it. And that's it. That's enough. That's too much. All right. Number 3 on the practice final. Okay. Oh wait, I have it somewhere. There it is. So number 3 on the practice final. Here we go. All right. What part of this is giving you trouble?
Letter C. I
I
forgot
see.
what the formulas were for the last 2 columns.
Gotcha. So I want to tell you for sure, I will give you all of the formulas, right? Just because the practice final doesn't have the formulas there doesn't mean I'm not going to. So on the final exam, there's going to be a box of formulas, probably on the very last page, right? You guys with me? All right. So with that said, what should anybody remember what this column should be? What should be at the top of this column here?
X P of X.
Yes, because when you add those up, what does that give you? It gives you the mean. Or another name for the mean is expected value. Okay. And again, this is a formula that will be sitting in your formula box on your final, right? Does anyone remember what goes here?
Is that the squared version? The XP of X squared? Or
No. X squared P of X. Don't just square this column. No. You do X, you can do L1 times L3, right?
Could you also do the X minus mu squared times P of X?
You could. That's fine. Just extra work, but that's all right. And then when you sum this up, that is a part of the formula for variance. And again, you probably can't read that, but that will be on your form. So whatever number you get when you sum this up goes right here. And then you subtract the mean squared. Does that sound familiar? Maybe. You're like, I don't know, man. Last 6 months have been blur.
yeah, kind of, not really. I don't remember that one.
Shit. I'm sorry. All right. That's how.
You don't need to square root or anything after that. You would just take the sum of.
What is this? Is that this?
No.
Variance.
That's the variance. And of course, to get the standard deviation, I have to
Square root it.
root. So the very last step is square rooting. Yeah.
Okay.
Okay. All right. Let me see. I've got. Everybody is wanting to chat now. Let's see. Wait a minute. Hold on. Where did I leave off? All right, here we go. I have problems making the graphs of section 12 with my calculator, but I'm about to get home from work since I don't bring it with me if I can't answer right now. Okay. So you're going to ask me later. Can we go through your specificities? So I think you mean my specific method of scientific method regard. I don't know what that means. Can we just do the whole thing? What whole thing? Yeah, specific. I understand. What whole thing though? Be a little more specific. Number 3. Oh, all right, sure, we can. Why not? Somebody else has asked me if there's a question. We'll do that in a second, Billy. Hold on. If there's a question on the final about linear regression and correlation, the graph itself. Oh yeah, put on your calculator. I told you this. So I'm going to want you to graph the scatter plot in the line of best fit on your calculator, and you're going to scan it, and you're going to submit that with your final exam work. Does that make sense? You're not going to have to graph it out by hand. Yeah. Okay. So somebody's requested that we look at this whole problem. It seems like a decent idea. Let me erase some of this stuff. Crap, let me just blah, 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 blah. Man, I need a giant eraser. All right, Jeff. It's just okay. Okay, just a minute. So, all right. This was just this. So again, L1, L2, L1 times L2, L1 squared. You can do L1 squared times L2, or you can do L1 times L3. I don't know if you guys remember that. Right? How do you get x squared p of x? You can either do x times x p of x. Isn't that x squared p of x? Right. So if I do this real quick, 3 times 0.11, 4 times 0.14, 5 times 0.12, 6 times 0.13, 7 times 0.5. I think I did that right. And then you multiply by another x. Are you guys following what I'm doing here? Right? No? The biggest mistake I see is people either just square this to go here. No, that would be x squared p squared, wouldn't it? That's not good. I want x squared times p of x. This will be 2.24. And of course, you could do all this in your calculator, right? Like the L1 and the L2 stuff up here. I'm just trying to do it real quick. Is that 4.68? I think so. Oh, somebody's chatting at me. All right, hold on. And then whatever the hell this is, I don't know, 24.5, I think. I mean, yeah, so I don't know, this, I really kind of hope this problem would not be that evil. How do I know it's a valid probability distribution? What do I have to check?
That p of x is equal to 1?
The sum. So if you just if you say this, I'm going to have to be a real dork and say which one. So yeah, the sum of them all is 1. And sure enough, if you do check, it is 1. Of course, would it be okay if it was 1.0003? Yes.
Yeah.
Would it be okay if it was 0.99996? Yes, that's almost 1. That's fine. What else?
That each p of x is less than or equal to 1? Or is it? Yeah.
Between 0 and 1. You can actually just say that in English if you want to instead of mathish. What's the probability x is greater than 3? What's a shortcut to get that?
Take 1 minus the probability of x being 3.
Yeah. If 3 is 11%, then x greater than 3 must be the rest, 89%. Bam. Or you can take all day and add these up. Right? Either way. Maybe not all day. And then you'll have on your formula sheet, if you see these, the time to use them is when I give you x and p of x, which I did. So there's no mystery about which formula to use, right? So if I just add this column up, I'll get the mean. I don't know what that is. 1.01, 1.16, 2.17, 5.67, is that right? Just doing it in my head. All right. I don't know if this is helping anybody, but is everybody doing okay so far? Somebody can double check that. And then sigma squared will be the sum of these minus the mean squared. How did I do what? Sorry? Oh, all right. You gotta stay with me now. You gotta stay with me. You just have to. Oops. What's the probability x equals 3? Isn't that 11%? Is that cool? The probability x equals 3 is 11%. Is that cool?
Yes.
Okay. So then what's probability x is greater than 3? The rest. Right? If 3 is 11%, greater than 3 is everything else. That must be the rest, 89%. Is that all right? Or you could add all of these up and you will get 89% because all of these is 1. So how much is this piece? 1 minus the piece I'm leaving out. That's all. All right. I don't know if anybody checked this for me. This sum, really, Jeff, in your head, 9.92, 10.91, 35.41. Is that what that is? Is anybody going to help me? All right, I'm going to pretend like that's what that is. Minus the mean squared. I mean, it really is just, you're going to have these formulas. I am not going to put this here. Right, you're going to have this formula. I'm not going to put this here. So, but you're going to look at this formula. You're going to cover up the sum. Oh, I need a bunch of xp of x's. Let me make a column of x times p of x's so I can add them up. Right? All right, hold on. I'm getting too many questions. Are we done with this problem? Is that all right? What's going on? And then whatever the hell that is, I already kind of did the.
It was 5.77, but
7.7? All right, that's pretty good, right? Come on. 7.7, really? 9.2, 9.4.8. Weird. All right, I don't know what I did. And then whatever that is, that's the variance. All right, so let's see. What is that? I feel like I'm wasting your time right now, but if nobody's gonna stop me, I'm gonna keep going. 35.41 minus 5.77 squared is 2.1171. That doesn't sound familiar to me, but. And then I take the square root of that to get the standard deviation, right? So I get 1.455 is the standard deviation. So then I can do this whole thing that we've done many times. Put the mean in the middle, go up one of these, go down one of those, and then just see how much I catch, right? So we've done that many, many times. Okay, so let me catch up with the chat here. Let's see.
For that question, how would you know if the data is normal?
Oh, all right. So even before anything, look at this data. Look at it. Where would the tallest bar be if I drew like a histogram for this? Which one would have the tallest bar?
4?
Why?
Oh no, it would be 7.
There we go. 50% of the data, 7. So wouldn't that be 3, 4, 5, 6, 7? Is that normal?
No.
No, not normal. Also, when you do this, I think you get 70 something percent. What's supposed to be within one step in a normal curve? How much of the data should be 68%? So it's not normal.
Oh.
But I already knew it wasn't normal just because it doesn't have the highest bar in the middle, right?
Thank you.
Well, let me see. What was the? Can we go over number 1, letter C for the practice fund? Okay. One's this guy. Oh, everybody's favorite. All right. I think you guys get so stuck with this, and you see this big ass P, and it means probability, and so you got to draw. And so some people think 95 is like $95. No, what does that symbol mean?
The 95th percentile
Yes. How would it look? 'Cause I
on
know
the right.
normal. Good to have to be way the hell up here because it's supposed to have a full 95% below it. Can you look up what that z-score would be?
1.645.
Yes. Now, real quick, I'm about to say something that not everybody's going to quite get, but that's okay. If this is, how much is in this tail here?
0.005.
No, just 0.05, right?
Oh,
And if
yeah.
I chop this off at 0.05, wouldn't there be 90% in here? Isn't 1.645 the z-score for a 90% confidence interval?
Yes.
So did you have to know any of what I just said to make any sense of this? No, but I just wanted to point it out. That's why I get a number that looks so familiar, because it's related to a situation that's really familiar. Okay. And then I just have to plug that in, and I know what the standard deviation is, and I know what the mean is. I'm sorry, I know what the mean is. Is that all right? Just to convert that back to a price of coffee, cost of coffee.
Yes, thank you.
Or is it kofifi? I don't know. Whatever you like to drink. Coffee, kofi.
For percentiles, we don't have to go all the way back to chapter 2, but I just remember when we were doing percentiles from chapter 2, if you got a number that was a whole number, you would average it with the next number. You know what I'm talking about?
Yes.
Okay. So, but then if you got a decimal, you would round up to the next number.
Yes.
Correct?
Take that number.
So what if you got a number that was a decimal, but it was already 0.5?
No,
Is that-
any decimal, you round up and take that one.
Okay, so if you happen to get, I don't know, 8.5, you would just round up to the 9 and then find the ninth number.
Yep.
So the fact that it's an 8.5 isn't enough to make it the halfway point between two numbers.
You're thinking wrong, because a whole number means you actually want the halfway point between two numbers.
Mm-hmm.
And it's just because of the way numbers work. I mean, if I do this, let's see, if I do this, the answer should be between the second and third.
Mm-hmm.
Sure enough, half of 4 is 2.
Mm-hmm.
So between the second and third. So it's
Okay.
just the way that things work, which is a very unsatisfying answer. But
So if you get something like 8.5, then you would just round up to 9, even though it's an 8.
what would you do with 8.472?
You'd probably round up to 9 as well.
Yeah. What'd you do with 8.507?
Yeah, same
Round
thing.
up to 9. So of course you'd round 8.5 to 9. Yeah. I know what you're thinking. It's like, that's the halfway point, but not the way that these things work. Yeah. Is that all right for 1C? You okay out there? I gotta catch up with these chats. Hold on. I am the one that asked for questions, and man, you guys are giving it to me. Oh, that was your question. Thank you. Sorry, Patricia. I was just catching up with this. I have a question on 85 and 98 on 9.5 homework. Okay.
It's mostly just like getting the correct claims and stuff, because it says it's believed to be, for 85, it says it's believed to be about 60 hours, but then the newly hired engineer hopes that it's shorter. So I just don't know whether I would do like the mean equals 60 or is greater than or equal to 60 or something like that, you know?
Again, very often, well, they have a setup for where a number comes from. So
Yeah.
why would this person hope it to be shorter than 60? Because it's been believed to be about 60. So that's where her claim comes from. She's not just coming in there going, I have no idea about shit, but I think it's less than 60. So it's establishes a number that somebody else can go, I think that's wrong.
Okay.
And that's your claim.
Okay, so that would be the claim. So then, like, that would also be the ha, because it's like just less than. So then the
So
ho
the
would be-
claim is the mean is less than 60.
Yep.
So then the ha would, or I mean, the ho would just be the mean greater than or equal to.
Yep.
Okay, all right, thank you. And it was the same for 98 also. It was similar setup.
Oh, cool.
So
All right.
that answers my question for that too.
A two for Emily. I'm sorry, Billy. Whatever you asked me to leave up, I must have taken it away. Did you need it back up, whatever it was? Was it this here? Okay, I'm gonna guess it was. I think I caught up. Wow.
Yes, that is it.
And don't forget, the video is up. Has anyone watched the video of the solutions for the practice final yet? I need to sit down and look through it because I can't remember if I did every problem. Let's see. Ask Jeff, man. Oh, you did? Do you remember if I didn't do 9 and 10? Oh yeah, thank you. That's what is on my mind. This number 9, is it 9? Yes, number 9 is from 10.2. And what was 10.2? What did we do with 10.2? Didn't we make it?
Extra credit.
Let me do one other thing, because to be honest, it's actually not from 10.2. If you want to try this out, if you did the extra credit, you want to try this out, because I am going to have a bonus question related to this. Just change these to sigmas. Like, because that's the section I made extra credit. This is actually from like 10.1, I think, where they use S. And that gets really freaky. So if you want to try number 9, it is extra credit, so you don't have to worry about it. It's going to be a bonus question. It's not going to be a normal question on the final. Let me see, another chat. 9 and 11. What was 11? Oh yeah, 11 I didn't do because just like this time, we did 11 together. So that one I remembered. 9 is the one I forgot.
Could you do 9 just out of curiosity for people who want to do the bonus question?
So, very quickly, because this is not everybody. The main thing I'll go over the main stuff. What's your claim in this problem? In fact, even if you didn't do this, can you figure out, just tell me what the claim is?
That the mean scores are the same for males and females?
Yes. So I'm going to let's call, because the men show up first, I'm going to call them 1. And then the women show up and I call them 2. So mean for the men is the same as the mean for the women. And there's several reasons why this problem needs to be taken down, not just because it was extra credit, but also because it arbitrarily puts people into 2 groups, which of course, I'm a firm believer that there's more than 2. So if you don't be offended by this problem, this is a problem from the 60s. Let's pretend when people were less enlightened. And if you have a problem with it, just keep it to yourself. Be quiet if you don't like what I'm saying. So which one would that be?
In the whole?
That's right. I get a kick out of it when you guys say that. Sorry. And then step B is Z or T, Zort, right? So what do you guys think?
Z, because the standard deviation is given?
Yeah, the population one's given, and both of
And
the
it's greater than
greater
30.
than 30 check, so I can use Z scores. I'm going a little bit quickly, but the alpha is 0.01.
Mhm.
How many tail test is this? That's one thing I didn't answer over here.
2.
It's 2 tail tests. So I'm going to be there and there. Alpha is 0.01. So could somebody help me out with what the Z scores are for that?
Is it 2.575?
Yes. Or 6. Either way, yeah. Let's say 6. This one comes from the T-score chart at the bottom.
Oh.
But 2575 comes from the Z-score chart, which is fine. Yeah. So if you can use either one. I really, do you guys, even if you didn't do this section, can you see how very similar it is? The only things that are different so far are there's no numbers here, are there? Because it's not a claim about numbers. It's a claim about 2 population means, how they relate to each other, right? So there won't be any numbers that show up in our claim or our hypotheses. If Z star is greater than this or less than this, we can reject and no, blah, blah, blah.
How would you solve for the Z score though? Is it the same?
No. So that's the next difference. That's that big ass formula we did because I've got double everything, right? So the Z star formula is X bar 1 minus X bar 2 divided by the square root, sigma 1 squared over N1 plus sigma 1 2 squared over N2. Everything's doubled. And I'm not going to spend a ton of time on this, but that's step D, right? So you would put in there 300.4 minus 290.6 divided by this, and just put all the shit in there. Are you guys with me? I'm not going to.
Oh, yeah. Okay, that makes sense.
You get your Z star, and then you compare it the same way you would normally. You just compare. You see, did you get into the rejection region or not? So really, the two main differences are no numbers in the hypotheses and big ass formula, because you need room for double everything to get your Z star. That's the only differences.
Sorry, the formula you just circled, the circle went through the first piece of it. It's root. Okay, thank you. Mean 1 squared over N1.
What? Sigma 1 squared over N1, sigma 2 squared over N2, yeah. You're welcome. Again, this will be a bonus on the on the final. It comes from extra credit homework. It's up to you if you want to try it out, but if you're semi-comfortable with hypotheses tests, this actually is not that different from a standard hypothesis test, right? I mean, the formula looks huge, but it's really, everything's just been doubled. There's two of everything because we have two samples. We have two populations. Samantha, I've got a frog in class. I love that. You had your head down. It looked like, sorry. Is that all right, everybody? For anybody that was curious? I mean, you just throw stuff in and you see what you get. I'll tell you what Z-star should be if you want to try this out. Where am I? 51 plus divided by, oh shit, the wrong thing in the wrong place. Okay. Right thing in the wrong place. 37, there it is. You should get 3.11, I believe. Yeah. So if you want to try it out, see what you get for Z-star, you should get 3.11, which would mean we found evidence to reject the null. So we found evidence to reject the claim. Okay, can we go over your exact standard hypothesis test in form? I don't know what that means. Do you mean? So let me show you this. The best handout to have sitting next to you when you do chapter 9 hypothesis tests is the very first sheet we looked at. Hypothesis tests, steps explained, right? So there's the 5 steps that I always want to use, right? Now, be careful. I really hope you understand. If you have a T problem, you should probably find one of the worksheets where it was a T score, right? Because I'm not going to ask you for a p-value for the T score. Are you with me? But these are the 5 steps. Is that all right? Yeah, the one in the book is it sucks. It's a dumb thing because the book uses the calculator way too much. So their worksheet is based on you already having put everything in the calculator. So their steps are kind of backwards. So no, don't do their steps. Yeah.
Professor,
Yeah.
I have a quick question for quiz 4.
Okay.
Number 2, the where it says P57.
Okay.
So you would look up the z-score for 0.57, right? Like the closest one you can get.
Yeah, the closest you can get to 0.57 in the body. And then
Yeah,
you
so
work it out. Yeah.
I got negative
No way.
1.58.
There's no way. So here, let me show you. Let me see why.
Oh, I read it wrong.
All right, let me see why you think that.
I was looking at 0.0.
Ah, that's so 0.57. I really want this to make sense. It should be above the mean because the mean is 0.50 percentile, right? So 50th percentile. So sure enough, here's 0.57 is like right here. So it should be 0.18.
Yeah, I just completely read that wrong.
Okay. Oh, I'm not even sharing, am I? Dang it, Jeff. Here we go. So here's 0.57. So 0.18.
Yeah. Okay. Thank you.
Look.
How did we get the z-score for in the hypothesis test practice for the percentages on number 1? We got a z-score of 2.576, and I'm just using it to like
Wait.
work for 2.
Number 1 on what?
The percentages hypothesis test handout.
Oh, all right.
I just can't remember how we got the z-score to like.
Find it. Let's see. Hypothesis. Where are you? Where are you? Hypothesis. Here we go. All right. We're talking about this. Is that right?
Yeah. So how did we get the z-score? Yeah. How did we get that?
So alpha's 0.005.
Uh-huh.
It is a one-tail test, right?
Yeah.
So then, yeah, if you look at the t-score chart,
Oh, okay.
let me pull this over here.
Yeah, because I was looking at the z-score chart and I was just like, that doesn't look like anything on there.
0.005, one tail, 2576. 2576.
Okay, that makes sense. So then, like, we just assume alpha, like if it's not given, it's 0.05, correct?
Well, yeah, not given as 0.05. This one was given as 0.005.
Yeah, I know. I'm just saying, like in general, for
Yeah.
like a
Yeah.
different problem. Okay.
Good.
Thank you.
Samantha.
I was trying to do the homework, the 12.2, the 59, the graph, and it looks like this. I don't know if you can see.
Oh, so all right, several things. All right, let me get my calculator up. Do you have the scatter plot turned on? So if you had second y equals, is this turned on?
Oh,
Is it? So do you see this?
yeah, now it's on.
And it looks just like this here?
Like this. I don't know if you can see.
Okay. I'm with you. So if it's turned on, okay, good. Now hit zoom 9. That's what you always have to hit when you have new data.
Now it looked like this. Okay.
Oh, so I don't know what happened to mine. You're oh yes, because I did all this weird. All right. That means dimension mismatch, which means your two lists are not the same size. If you look at your lists, you left something out. So if your two lists are not the same size, that means that one point is missing part of it. Do you understand?
Yes.
Okay, so you left some data out. So I don't know what's in your lists right now. Is it a specific problem or are you just trying this out of nowhere? So maybe your lists.
No, it's the 59.
So you have the data from 59 in your calculator?
Yes.
And so when you look at the lists, when you hit stat edit, are the lists different sizes like this?
On the book is different.
I know. All right. So let's see, what'd you say, 59?
Yes.
So 59. You got, isn't everything a complete point? Yes, you got this and this. This should be list 1, list 2, and then this is the rest of list 1 and the rest of list 2, right?
Yes.
Now listen, if you look at list 1, can you look at your lists? Can you pull them up on your calculator? Can you look at your lists?
Yes.
Okay. If you scroll down, are list 1 and list 2 the same length, or does one stop before the other one?
One stop before.
Ah, so you left something out. Shouldn't be, they should be the same length, right? Because doesn't every year have a PPP? Do you understand what I'm saying? No.
Kind of.
No. So all you did was you left. So what's the last numbers in your lists?
3500 and 9900.
I don't understand that. Can you show me your lists? Hold on, put it up there and hold it there for a minute. Hold on, stay. Hold on, stay. I gotta figure out how to do this. All right, there you are. All right, so, wow, I see. Okay, all right, I understand now. All right. So let me tell you. Let me see, there we go. Okay, so let me tell you what's going on. This should be, list 1 should be the years.
Oh.
PPP.
Oh.
That's the
Now I
2
understand.
variables. You have to have 2 distinct variables. Yeah.
Okay. Thank you.
Well,
Now I understand.
I just did that by hand. I don't know what that means, Billy. You just did what by hand? Oh yeah, the scatter plot, that's fine. In fact, I kind of prefer the scatter plot done by hand, but practice with the calculator, there's nothing wrong with that. Yeah. Okay. Yeah, understood. That's fine. Oh, you have a question on number 60? Oh, okay. All right. Let me show you. I thought I did this. All right. The following table shows poverty rates and cell phone usage. So which thing did they give us that I don't give a shit about? Yeah.
The year.
Good. So this is my X's and this is my Y's.
Okay. Do you want that done by hand or just a picture of the calculator?
Either way. 12.1, is that what section is? No, this is 12.2. This is just making scatter plots. But when you get to the one we have to calculate R and all that stuff, you should probably try to do it in the calculator to get practice with the calculator, right? Okay. So as long as eventually you do them in the calculator for practice, good. That's good.
I had a question from quiz 5.
Yeah.
So it was under, let's see. Oh yeah, so for 1A on quiz 5, I said that it was normal because the n times p hat was greater than 5. And
So
then you said it was 1A from quiz 5.
So you said that the what now?
I said that n times p hat was equal to 2, let's see. Wait, what did I say? 201.134, which is greater than 5, so it was normal enough. And then you said that that wasn't enough information.
Yeah. What else? Anybody? So she did n times p hat. and she stopped. What else should
Was it
she?
at N times Q?
Yes, you got to do n times n times q. Yeah.
I did the same thing.
Oh, okay. There you go. So it kind of sucks because means are easier. N greater than 30, done. N greater than 30, done. Percentages are a little more, they need some more help. They're like, help me, N times P. I need more help. And you got to do N times Q. You got to do both.
Okay. Got
Quiz
it.
5, what number was that? I'm sorry.
That was 1A.
1A on the quiz 5. The one that I called quiz 7 because I was having a rough week. Every week is a rough week. What are you talking about?
Okay, so can we do that number 1 just really quickly? Americans who lost someone due to inability to pay for health care. P hat is 201 and Q hat is.
No, stop. No. What is P hat? What does it mean?
The percentage?
Percentage. I love it. Right? It's a probability, really, but probabilities are percentages. I love it. The probabilities, though. So what's the biggest it could be?
1.
1. So don't tell me it's 201.
Oh, 201 divided by
Yes.
total number of Americans, which is 1488.
Yes.
Okay, thank you.
And then Q hat will be the rest compared to 1. Yeah, you got it.
Wait, hang on. You said 1488?
Listen, there were 3 different versions of this quiz.
Oh, okay.
And that helps me out with the special people that cheat and they give me answers to a different version than the one they took. And I'm like, oh, that's easy. 0.
Conclusion of number 1. I think you circled it because you didn't like the way that I worded it. I said we can conclude that the interval this to this contains the true percentage of blah, blah, blah. So how do you want us to word that part?
Oh, we can't. That makes it sound too definitive.
Okay.
Are you 100% certain?
No.
No, so you got to include how confident you are.
So
So
we
just say we can include, say we are whatever percent
okay.
confident. Yeah, whatever version you had. We are whatever percent confident.
Confident that the, okay, gotcha.
Yeah, so the we can conclude is the part that you have to change. Everything else is fine. It sounds like. I like it.
Let's see what's
I just can't get over that frog hat. That's kind of awesome.
So if we answer a P hat with a decimal instead of a percentage, it's wrong. It has to always
No, dude, no. In fact, when we're doing work with them, they need to be decimals because that's the number. The percentage is something humans made up just to have it make more sense to us.
Okay.
So I want you to understand, it is a percentage, but we want to write it as a decimal when we're going to do work with it.
Understood.
The only reason I was making it clear that it was a percentage is so that you remember it's a ratio. So many out of so many, right?
So I have a question for from the midterm.
Yeah.
Number 2, it's a probability question, and I'm just struggling with the probability of something given another thing.
Is that the pieces of paper?
My version was students majoring in English.
The piece of paper is on the practice files, right? So let's see. Oh yeah, this problem. So I tried to make a problem that was exactly like those 2 problems in the homework. The one about the Latinos and the death penalty, whatever, and the one about same-sex marriage and all that kind of stuff. Is that sound at all familiar? Yeah. So the first 3 A, B, C on number 2 on the midterm, no work. They just relate to one of the 3 percentages probabilities that I give you in the write-up, right?
Oh, yeah.
Yeah. The first one that needs work is part D. And part D is actually a 2-step problem. So I kind of make up for the fact that the first 3 have no work. The last one I make it have twice the work.
Then I probably did part D wrong in my correction. So how would you do that?
The formula for that is E and C, the probability of E and C divided by the probability of C, right?
Okay.
And you don't know the probability of E and C. But
Yeah.
the formula for that is the probability of E times the probability of C given E. And don't you know those two things?
Yeah, you saw for that and see. Okay.
So that's why it's that you write down the formula for what I ask you for, and then you go, well, shit, I don't know the top of this. Then you write down the formula for that. And then you go, oh, good, I got everything I need.
Okay.
Yeah.
Thank you.
You're welcome.
For quiz 5 again, I think it was third. Ooh. Hang on.
I'm not laughing at you, I'm laughing near you.
3. Okay.
Quiz 5, okay. Which one, sorry?
I think it was 3A. Yeah, 3A. Create a 98% confidence interval for both sets of data. Is there evidence that the population means are different? I got that wrong. Because I said, yes, there is evidence that the mean, I think.
So listen, if I had a confidence interval for one mean went from 5 to 11, and another means confidence interval went from 20 to 28. Isn't that evidence that the two means are different? I don't know what either population mean is, but I know that one interval goes from 5 to 11 and the other one goes from 20 to 28. Why would that be evidence that they're different? Because they don't
crossover.
Good. The intervals you created for that.
We do crossover.
Oh, shit. Yeah, guys, don't forget, tomorrow is a whole other day of this. Isn't this fantastic? You can one thing that'll be new for tomorrow is quiz 6. I will have graded those. We can work on corrections to that quiz tomorrow together in class. That's great. We can do more from the practice final. You can bring more questions from homework, right? So we're going to do this whole thing again tomorrow. Everybody's always like, God damn, can't we just slow down? They're not going to ask it. Here it is. here's that time. So let me know. Nobody's asking anything. So now's your time. Go over the question on the, of course, we've been doing that. Which one?
Sorry, I mistyped. I meant question 4.
Sorry? Oh, you meant
Sorry, question 4.
4 on the practice final. Okay. I thought you were just asking in general. All right, let me see.
No, I forgot to type 4.
I understand. I can relate. I mean, I put a whole wrong quiz up, so I can't complain. All right, so this beautiful problem. I love it. It's a pretty problem. So can you see how to identify what kind of problem this is? Do you understand how important that step is? You're going to have all the formulas, but which one? You got to know what kind of problem this is. So can you start identifying like 35, 9%, probably that 4 of them? I mean, what does that feel like? What can you identify? What is 35? What is that, the variable for that? That's the sample size, that's n. What is 9%? 9% believe that children shouldn't get health insurance. They're fantastic people, I'm sure.
Is it the N and the P?
Good. P is 0.09, so then Q is?
0.91.
So now you start to see what kind of problem this is, right? It's an NPQ problem. With the probability that 4 of them. So what's that formula that has the N's, the P's, and the Q's in it? So what's really important here is how to identify what kind of problem it is. Because I have people trying to make z-scores on this problem. And I'm like, I never said it was normal. What's happening? Why are you making z-scores? This is an NPQ problem, right?
Not all abnormal problems are NPQ problems, though.
Very true. Very true. So what is it about this problem that tells you it's an NPQ problem? I can identify N.
Probability.
Probability of something, and that means the probability of not that thing is also there, right?
Okay, so probability is the key word that tells you it's NPQ.
Well,
But-
no, because I could use this word for z-score problems and for, right? So it's really the fact that they took a sample of people, and I know there's a probability that the people did something, which means there's a probability that the people did not do that thing. So there's two outcomes, binomial.
Is this the one where we use the n count x or whatever?
Yes, choose. Yes,
Okay.
this will be 35, and I want to choose 4 of them. So that means I got 4 successes, and I got how many failures?
31.
Good, because I got 35 total people. Remember the exponents have to add up to be the total number of people. And then you throw in the old calculator and whatever, done. Done.
Is there a way that we can check or see what percentages we would need to get on the final and just in general to to see what
All right,
for final scores?
I did say I would put those in there. That's what I'm going to work on this afternoon. Well, this afternoon, tomorrow, as soon as I get done grading quiz 6, I'm going to update all the grades, update your average grades, and then add what you need to get on the final to get a B, what you need to get on the final to pass, right? Those kind of things. Is that what you're asking for, right?
Yeah.
You know, I always do that every semester, so you know what your target is. And you're all like, I never had you before, dude. I don't know this shit. That's why I told you. It's all good. Was that enough of that number 4 problem? You guys, you know how to do the rest of that?
I think I got 0.1846 for that one.
Yeah. I have no idea what the answer is. Sounds like that's what it would be. But I'm talking about like part B.
How would we find the mean and the standard deviation?
N for part B is 512, right?
Mm-hmm.
We left the 35 behind. P is still 0.09. Q is still 0.91. Is that cool? Everybody, some people start to change these. How can you change the percentage of Californians who believe this? You can't just change that by me writing a question on a test. Suddenly somebody goes, wait a minute, maybe they should get insurance. No, right? So the P and the Q stays the same because that is just the way things are. So what is the formula for the mean? It's a beautiful little formula, the best formula ever for the mean. For NPQ problem. Remember that?
Yep.
Yeah, and then you just got this little, and those are the best ones. Don't have to make a table, none of that shit. And it makes sense. If 9% believe a certain way, and I can take 512, wouldn't it be 9% of 512 that I would expect to believe? Yeah, so that formula matches with what we would do.
And then to find the min and the max, do we just do 2 standard deviations up and down? Okay.
So 2 steps up, 2 steps forward, 2 steps back.
Thank you.
It's a song from my days. And Save me and everybody else from me singing.
I have a question about 11.2. So they want you to find the hoe and the haw of that. Is the claim always like what that expected is? Would that typically be the claim? So for 72, it's talking about a 6-sided die. So it's like the 6-sided die is fair.
All right. I didn't say this, but I was hoping you guys would understand. You definitely do not do this.
Well,
Solution sheet. Definitely don't. Obviously not. You do exactly what we did together, right?
okay. So no null hypothesis,
Nope.
none of that?
Like I said, I could have made these into full hypothesis tests. Decided not to.
Okay.
I'm going to focus on the two most important steps. How far did your sample get away, and how far, where's the rejection region start, right? So you can see if it got far enough away.
Okay, thank you.
You're welcome. So basically, any sheet they try to give you, sell you, you go, no. Nuh-uh. Nuh-uh. All right, sorry. What were those two steps again? What I just said. So it's looking up the chi-square on the chart to figure out how far you've got to get, right? So look up the chi-square on the chart to see how far you got to get, and then calculate chi-square to see where it falls. So this one comes from the chart, and this one comes from the formula. Oh man, I missed the formula. We save it. There we go. Right. Is that all right? So calculate one, look the other one up, compare them, see if the sample got far enough away. Yes. Okay. But you can see how this is really a hypothesis test. We're just focusing on two of the steps.
And the formula is the sum of 0 minus E.
No. Stop. Somebody help us out. What is this?
Observed minus expected.
Observed minus expected squared divided by expected. Yeah. So that's that problem we did with the cholesterol levels, the grade thing that we did earlier today. That was the one about the M&Ms. Observed minus expected, all that kind of stuff. Yeah.
And for that one, we're assuming the alpha is 0.05 since it wasn't.
Yeah, anytime they don't say.
Okay.
Yeah. 105 is the most often used. It's the standard usage, and then you have to explain why you're not using it if you're using something else. Oh. And that was, when I said that, it was for real life. So you guys don't have to explain, they'll just tell you. In real life, if you're like being more or less stringent, you have to explain why. In real life. If there's not gonna be any questions, I'm gonna sing to you guys. Strangers in the night.
So I have a quick question about.
See, I knew that was quick. I knew it was quick. All right, go ahead.
Okay, so on verifying if a probability distribution is valid for when we do the px and then p of x. So it's if the px sums up to 1 and something else. Oh,
yes,
close
yes.
to 1.
So what is the second thing? So sum of p of x has to be 1 or close to it, because it could be rounding, right? And what's the other thing to check? For a probability distribution, the probabilities have to sum up to close to 1 or 1. And what else?
The number has to be greater than, or the sample has to be greater than 30?
No. So to be a valid probability distribution, all the probabilities have to add up to 1, and all the probabilities have to be in between what two things? What's the biggest it could be? What's the smallest the probability could be?
0 and 1.
There it is. So you got to check those two things and say those two things, right?
Okay, so I just write the P of X adds up to, almost
Make sure.
1.
Yeah. You make sure it does. And then you also say check and say the probabilities are between 0 and 1.
Okay.
Yeah. Are we all out for today? What's up? Is that everything? Does the popcorn stop popping? No, you don't understand that reference. This is like waiting for the popcorn to stop, right? You're like, pop, pop, pop. Don't burn. Should I stop it? I have tones. We've just been tons. Oh, well, ask away. That's the whole point. We've been skipping around because it's based on what people ask. That's all. That's what today is. This is today when I don't have anything structured. It's all what you guys want to talk about. That's what today is, and that's what tomorrow's going to be. More of this. More of Jeff threatening to sing.
Can you talk about what to do for the hypothesis testing when you don't get either standard deviation, like for the population or the sample?
Did you run into a problem like that?
I thought there was one on the chapter 9 homework.
Did they give you a list of data?
I don't know. I'd have to go look. I can, if
It's
you want, we can
either-
skip it and I can try to find it and then ask tomorrow.
Listen, they have to. So it's either that they gave you a list of data, so you got to use one var stats, right? You have to put it in the list one, do one var stats. So you calculate what X bar is and you calculate what S is. Are you with me?
Yes.
Or it's a percentage problem, right? It's a test about a percentage, in which case they don't have to give you much at all. Yeah, in fact, there's one of the problems in the quiz. It's got 2 lines to it. It's very little information. So, but yeah, for a percentage problem, I barely have to give you anything. They could be really quick.
Okay, I'll go back and check it out.
I feel like I've not had enough time to go back through everything. I'm still in the process of doing homework right now, but tomorrow I know I'm going to have a lot more questions.
Yeah, it's fine. That's fine. I figure instead of loading you down with more required homework today, I would start looking at the practice final. Because now you have time to think about what you want to ask tomorrow instead of working on new homework for tomorrow, right?
Yep.
Yeah. So I have no problem with ending things soon or now and then coming back tomorrow, and you guys have that time between now and tomorrow to gather your thoughts and come with questions. I mean, that's fine with me.
Yep, that works. Thank you, Professor, and I'll probably come in for office hours tomorrow.
Yeah, okay. And on Friday, I'm actually on jury duty. Yay. I know, it's fantastic. Thursday, I love the looks I'm getting. Thursday is the final, and I'll be in office hours like at 12:30. Yeah, that's fine. Yeah, okay. Private chatter, that sounds fine. And again, so if you guys are cool, we can end today, and you can go do quiz 6 if you haven't done it yet. You can finish up homework, you can whatever, and then come ready tomorrow with all the questions. Do we need to explain why we chose our answer on number 5 for section 11.1? Wait a minute. So, what is that question? Somebody's asking about number 5. Oh yeah, that one's like a reading problem, right? So number 5 on 11.1 is just read the book. Yeah, exactly. They just give you the answer in the book. You just got to read the book. I know. There's ways to get out of it. I know. I'm just gonna go dressed up like R2D2 and tell them that I can smell guilt on people. They should let me go, or they might detain me. And yeah, oh God, I wish that would. I don't know, dude. I don't want to know. And whoever else is like, oh, good, you're one of us, brother. I'm like, I need to go now. Let me get out of here. Yeah, you never know nowadays. Could be one of my students who's out there getting signals from Q. Sorry. I generally try to keep my politics out of everything. As you've noticed this semester, I haven't had the greatest luck at that because recent events have made it nearly impossible to do that. Wait a minute. So there's a quiz tonight. There's a quiz that started last night. There's a practice quiz. That's right. So that's not bad to look at. And the homework probably for hypothesis tests. It will help prep you for that. Yeah. Okay. You're welcome. All right. I think you guys just need me to say, that's it. Class is done. Yay.